This lesson will be a supplement to the Radiolab episode on colors. And in that episode, we learned about the idea that language may influence the perception of colors. So when cultures have different languages, they may be carving up their experience in different ways. And in the realm of colors, different cultures have different terms for colors. Some languages have lots of color terms. Other languages have fewer color terms. Now, the suggestion here is not that if a language does not have a term for a color, that the people can't see the color. That's not the argument. The argument, though, is that color terms, color concepts, do subtly influence the processing of color. So the argument here is that the language system can influence perceptual systems. So let's take a look at some experiments along these lines. We were introduced to the Himba tribe. So the Himba have words for colors, but they don't overlap with the words that we use in English. So for example, the Himba do not have separate words for blue and green. So what we call blue and green would be covered by the same term. Blue and green would fall into the same category for the Himba. On the other hand, the Himba have several words for what we would call green. So they carve up the green part of the spectrum with several terms, and we typically use one. Now, an experiment that was shown on that little video here was a sort of a demonstration of an experiment, but the task goes like this. So the subject is looking at a screen, and they see a whole bunch of tiles, and the tiles all have the same color except one, the oddball. Now, for us English speakers, it's pretty clear. This would be an easy task. The blue one here stands out, right? So the blue one is the different one. Now, this is a reaction time task. So when the stimuli comes on the screen, the researchers are just measuring how long does it take to spot the oddball. Now, interestingly, though, English speakers are faster on average than the Himba. So the Himba are slower on average than English speakers. And of course, that was interesting because the Himba do not make a distinction in their language between blue and the green here. Both of these colors would fall into the same category. So it raised the possibility that perhaps the Himba were taking longer because their language was not reflecting this discrimination. Their language was not making this distinction in color. Now, take this stimuli down here to English speakers. This looks like all the tiles are green. And it turns out this is challenging for English speakers, and English speakers have a longer reaction time compared to the Himba. It turns out that this tile here, the one over there, this tile here has a slightly different shade of green, and Himba speakers are quicker when the stimuli look like this than English speakers. Now, why would that be? Well, again, what is happening here is this tile here, this shade of green, is falling in a different color category for the Himba, but not so for the English speakers. So the results of this type of experiment suggest that the language that we have, the way we carve up the color spectrum, may be influencing perceptual processes, and then that shows up as reaction time differences. Now, another example of this is the work of Lera Boroditsky, and she studied English speakers and Russian speakers, and again looking for any kind of influence of language on a simple perceptual task. The task is pretty simple. What happens is the subject is looking at the screen, and a square of a certain color flashes up, in this case blue. Right? And then a moment later, so then it disappears, and a moment later 2 more blue squares show up, and the instructions are to simply, as fast as possible, determine which one matches the original stimulus. So in this case, if this was the first stimulus, then the one on the left is a match. The one on the right is a little bit lighter in color. If this is the original stimulus, the one on the left again matches. The one on the right is a little bit darker. But importantly, for English speakers, all of these variations of blue are still blue. They're just variations of blue, so it falls into the category blue for the English speaker. That's not the case for Russian speakers. So for Russians, they have 2 separate words, one for darker shades of blue and one for lighter shades of blue. And so notice what that means then in a task for this set of stimuli. When this first tile comes on and they're given a choice between the left and the right, notice though the two choices fall into different color categories. So here we have a darker blue and a lighter blue, and the Russian speakers would use two different terms to refer to these different colors. On the other hand, if this is the original stimulus, then the left and the right here both fall into the same color category. So what they could do is see if there's any difference in reaction times in these for English and Russian speakers, to see if they could find any influence of language on color perception. Well, they found something interesting, and it even surprised Boroditsky. For English speakers, they found the same reaction time for both of these conditions over here. But for Russian speakers, they were faster when the two colors that they had to choose from were in different categories. So in other words, Russian speakers were faster for this task than for this one over here. English speakers were equally fast for each of these. And remember, for English speakers, all of these colors are in the category blue. But for Russian speakers, this scenario here is giving them a choice between two colors that fall into two different color categories. And so again, the suggestion is that this is an influence of language. The fact that the Russian speakers have two different concepts, two terms for these colors, is somehow facilitating this perceptual discrimination task.